Okay, gas chromatography. Gas chromatography is a type of column chromatographic technique that can be used to separate volatile organic compounds, mobile phase, inert gas, nitrogen, helium, hydrogen, carrier gas, stationary phase, liquid solid, mobile phase, inert gas like nitrogen, helium, hydrogen is a carrier gas, and stationary phase, liquid solid. Principle of gas chromatography. Gas chromatography is based on the principle of partition differential distribution of in volatile compounds. Gas in two phase, a liquid phase covering the adsorbing surface and a gaseous phase of the eluting gas. With a fixed set of the parameters, length and diameter of the column, temperature, nature, and flow rate of the eluting gas, etc. Gas chromatography, it is the diagrammatic representation of gas chromatography, inert gas, sample injector, column, detector, recorder. Types of gas chromatography, gas solid chromatography, GSC. The stationary phase in this case is a solid. It is the affinity of solutes towards adsorption onto the stationary phase, which determines in part the retention time. The mobile phase is, of course, a suitable carrier gas. This gas chromatographic technique is most useful for the separation and analysis of the gas like methane, carbon dioxide, carbon monoxide, etc. Gas liquid chromatography, GLC. The stationary phase is a liquid with very low volatility, while the mobile phase is a suitable carrier gas. GLC is the most widely used technique for separation of volatile species. Principle of gas liquid chromatography. Gas liquid chromatography runs on the principle of partition. In GLC, the components of vaporized sample are functionated due to partition between a gaseous mobile phase and liquid stationary phase held in column. Gas liquid chromatography runs on the principle of partition. In GLC, the components of vaporized samples are fractionated due to partition between a gaseous mobile phase and liquid stationary phase held in a column. Working principle, sample injection or a small amount of liquid sample is vaporized in the injector and carried into the chromatographic column by the carrier gas. Separation in the column, the components of the sample interact differently with the stationary phase and are separated based on their boiling points, polarity, or affinity for the stationary phase. Detection and quantification, the separated components pass through the detector, generating signals that correspond to the concentration. The separated components pass to the detector, generating signals that correspond to their concentration. The output is chromatogram with peaks representing different compounds. Data analysis, the retention times and peaks areas in the chromatogram are used to identify and quantify the compounds in the sample. Carrier gas supply, sample injector, sample injector, stationary phase, chromatographic phase. Instrumentation of GLC. This is the carrier gas, flow control, injection port, column 1, recorder, detector. Mobile phase carrier gas. The carrier gas, often helium, nitrogen, or hydrogen, is an inert gas that transports the sample through the column. The flow rate and pressure of the carrier gas are controlled by flow controllers or pressure regulators. Sample injection. The injector introduces the sample into the gas stream. This can be done using either a syringe or an automated sample injector. Injectors can be of different types, such as split, place, or on column injectors, depending on the analysis. Column. It is part of GC which decides the separation efficiency. Column is made up of glass or copper. Columns are two types based on usage. Analytical column, it has length 1 to 2 meters with 3 to 6 millimeter diameter. Preparative column, it has length 3 to 6 meters with diameter 6 to 9 meter. Okay, preparative column, it has length 3 to 6 meters with diameter 6 to 9 millimeter. The column is the heart of the GLC system where the separation of compounds occurs. It is typically made of stainless steel or glass and is filled with a stationary phase, which could be a solid adsorbent or a liquid coated support. Capillary columns which have an inner coating of the stationary phase in a very small internal diameter are also commonly used for high resolution separations. Column oven. The oven controls the temperature of the column. The temperature programming can be used to optimize the separation of compounds with different volatilities by starting at the lower temperature and gradually increasing it during the analysis. Detector. The functions of detectors is to measure the small amounts of separated components present in the carrier gas stream leaving the column. The output from the detector is fed to a recorder which produces a chromatogram. In some cases, gas chromatographs are coupled to the spectroscopic instrument mass and IR. Flame analysis detector sensitive to organic compounds widely used in hydrocarbon analysis. Thermal conductivity detector, universal detector that responds to change in thermal conductivity of eluent gas. Mass spectrometer provides detailed molecular information in highly sensitive and specific. Electron capture detector, highly sensitive for halogenated compounds and nitro compounds. Recorder, it is a device that draws the chromatogram that results from a chromatography process in paper. The detector signals are sent to the data acquisition system or computer that process the data and displays it as a chromatogram which shows the peaks corresponding to the different compounds. Advantage of GLC: high sensitive, qualitative and quantitative analysis are possible. Analysis is highly accurate and precise. Application of gas chromatography, qualitative analysis, identification of the compound. The unknown sample can be identified by collecting the effluent and analyzing it by GCMS or GCFTIR. In industry, ultrasonic detector in GC are useful in the field of food products. Large number of industrial products are separated by gas chromatography. For example, crude petroleum products, gasoline, hydrocarbons, nitrogen, and sulfur compounds have been separated by GC and identified by IR, NMR, UV, and mass technique. Quantitative analysis, one way of determining the amount of the solute by GC is to collect the sample components and they are eluted from the column and can be analyzed by the appropriate method. Recorded chromatograms can be used for the quantitative determination of known compounds. The peak is the only source of analytical data. If the peaks are sharp, narrow, and reproducible, it is possible to convert the area under the peak in a chromatogram to quantitative measurements simply by comparing them with standard graphs of the appropriate compounds. Elemental analysis, an important use of GC is the determination elements carbon, hydrogen, nitrogen, oxygen, sulfur in organic and organometallic compounds. Okay, it's all about gas chromatography. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you again.